Well, the question here says the sketch below are the graph of f of x and g of x. A and D are the x-intercepts of f. B is the common intercept of f and g. C and D are turning points of f. The straight line g passes through A. Well, question 1 says, let's see, and then question 8.1 says write down the y coordinate of B. So the y coordinate of B is basically this point here. So let's just say the points that we have here, this point. Now I'm gonna write here question 8.1. 8.1. Now, by definition, okay, we know that because B is the y-intercept, we know that the x-intercept is when we make, the y-intercept is when we make x is equal to 0. In other words, it's just the constant value of the y of the straight line. When I look at this straight line here, this straight line, we have the gradients, and then we also have the c value. So this is the c value. This is the y-intercept. Okay, the c value stands for the y-intercept. So here y equal to 12. You can also put set x equal to 0, and then whatever m will be times 0 will be 0, and then y will be 12. So y is 12. Now question 8.2. 8.2. Sorry, I meant 8.2. Over here we know this is 12. 8.2 says calculate the coordinate of A. Well, we can see that A here is the x-intercept. Okay. So on the right over here, we're looking for the value of A, which is like the coordinate of A is xy. Now, from the question, we can see that A is the x-intercept, meaning the y value is 0. So basically, A is of the form x0 because y is 0. Now, what do we do from the question here? If I look at it down here, okay, A lies on G, and is also a point on C. If I look at G, I'll make there 0, but I'll still have, like, if I make G of x0, I still have like 2 unknown here, m and x. Over here, if I make this 0, I have like 1 unknown, so it's gonna be easier to work out f of x. So f of x, which is f of x is something as y. So y equal to x minus 2 to the power of 2 times x minus k. Okay, we already have like a point. So over here, meaning y equal to 0. Okay, I can sub in the value of y by 0. So this will be I'll sub 0 for y. Okay. If I sub 0 for y, and then I will still have unknowns. So what can I do? I can first find the value of k, because we already have a point here. At this point, B lies on the parabola. Lies on the cubic function f of x. So I can sub this point here in this equation. So this will be then a 12 for y, and then 0 for x, and 0 for x there. And then this will be equal to 0 minus 2 to the power of 2, open bracket 0 minus k. Okay, and this is 12 equal to 4 times negative k, so it makes negative 4k. And then and this means that if we divide both sides by negative 4, k will be equal to negative 3. So we have like the value of k. Now that we have the value of k, we can substitute f of x. So f of x then will become x minus 2 to the power of 2, open brackets, and then x minus k, so that makes plus k, because minus here will be will be plus. So f plus 3 equal to 0. Sorry, f x plus 3 then. Now, at this point here, A being the x-intercept, meaning I want to substitute y by 0. So f of x is 0 here. And then this will make 0 equal to x minus 2 to the power of 2. And then x plus 3. Okay, this is true if x plus 2 is equal to 0 or x plus 3 equal to 0. So x minus 2, I mean, that's x minus 2. Now here x is equal to 2, or over there x is equal to -3. Now when you look at the placement of the points A is on the left hand side of 0, meaning A is the negative value. So A is just the x value of A is this -3. So therefore A is the points -3, 0. Somehow we already find this x is equal to 2. This is the other intercept. Okay, this is the point D. So it wasn't asked here or yet. So we find the value of A. Now, what else? The question says here, if k equal to -3, calculate the coordinates of C. All right, let's see where C is there, that point. All right, C is this point. C is actually the turning point or the maximum here. And then we know here by the turning point, the tension line is always horizontal, okay? Meaning the gradient of the tension line is 0. Or the gradient of the tension line is the same thing as okay, I prefer to say this way. The tension line here has gradient equal to 0. And the gradient at C at this point is just f prime of x. Okay, I'm gonna write here. Question 8.3. Move. We're looking for the contour of the point C. Okay, and then we see that C being a maximum or at a turning point, whatever we can call it, like turning point maximum or local maximum, highest point at the turning point. We know that at that point the gradient of the function, okay, is equal to, I'm gonna write here, m, the gradient of f of x, okay, is equal to the derivative of f of x, and then d is equal to 0. Now, so we have like f of x equal to f of x was equal to x minus 2 to the power of 2, and then x minus k, and then k was found to be -3, so minus 3. That makes that. Now we can expand this and work out the derivative, okay? So now f of x will be equal to x minus 2, and then x minus 2, and then x plus 3 there. Now, let's first do x times x, and then x times -2, negative times x, -2 times 2, and then this will be x squared minus 2x minus 2x plus 4, or this times x plus 3. We can simplify this. That makes x squared minus 4x plus 4, and then times x plus 3. And now we can also do x times this, okay, and then this times that, and then this times that, and then that times that x, and that 4x, and then the negative and the 4 there, and then this will just be equal to x cubed plus 3x, and then negative 4x squared. Yeah, x squared times x makes x cubed, x squared times 3x squared, and of negative 4x times x will make negative 4x squared, and then and then x here times that makes positive 4x, and then I'm gonna write here the denominator here 3 times x squared, that makes 3x squared, and then 3 times negative 4x, that makes negative 12x, and then 3 times 4, that makes positive 12. Now this can be written as x cubed, and then let's see if we can combine. Let's first double check. We did this x times that makes x cubed, x times negative 4x. Okay, to avoid confusion, I prefer to go over it a little bit. Now we will do x squared times x, and then x squared times 3. So this makes x cubed plus 3x squared. And now we're going to do this 4x now times x, that makes negative 4x times x, that makes negative 4x squared. Negative 4x times 3, that makes negative 12x. And now 4 times x makes 4x, and then 4 times 3 makes positive 12. And now let's see if we can simplify, combine like terms. We have like x cubed plus the terms that end with x squared are this and that, so that makes negative x squared. And then terms that end with x, yes, this one and that one, that makes negative 8x plus 12. So this is like the cubic function f of x. Now I need to find f prime of x, so this will be then f prime of x. So the 3 will be, this become, the first term will be 3x to the power of 2. The second term then will become negative 2x. Excuse me. The third term will become negative 8, and then the last term is just 0, because the derivative of a constant is just 0. Now, and then we're going to set this f prime of x equal to 0 according to the definition wrote here. Let me move my board over here. We're going to set now put f prime of x equal to 0. So this was x cubed minus x squared. Excuse me, x cubed minus 2x equals here 3x squared minus 2x minus 8. So 3x squared minus 2x minus 8 equals to 0. Now we can solve this by factorization. Okay, we can do we can factorize. Let's do 3 times 8. 3 times 8, that makes negative 24. That makes negative 24. But the factors of 24 are like 1 and 24, 2 and 12, 3 and 8, 4 and 6. That's all. Now we're going to look at the list of the factors. Which couple will make negative 2? Okay, the couple that can make negative 2 is positive 4 and negative 6. Okay, now we're going to split the 3 terms here into 4 terms. That will become a 3x squared plus 4x minus 6x minus 8 equal to 0. Now, note that this is just negative 2x. So now over here, we can factorize now by looking at the common factor of the first terms. Yes, x is a common factor. And then the common factor for the last terms is negative 2, the common factor. Now, if I take x as a common factor over here, I'm left with 3x plus 4, and the negative 2 as a common factor here is going to be 3x plus 4 also. Okay, note it's negative that is taken out. If you times, you got negative 6x, negative 2 times 4, you got negative 8. And then you must always get this and that common here. Otherwise, you didn't select the right couple here, or factor, or you didn't factorize correctly here. Now, this is just equal to x minus 2 factors of 3x plus 4 equal to 0. So this means that x minus 2 is 0, or 3x plus 4 equal to 0. Now, this means that x is equal to 2, or x equal to negative 4 there, and then x is equal to negative 4 over 3. Now, if I look at the graph of f here, I can see of the two values of x, one positive and negative, c must have a negative x value because it is on the left hand side of 0. So over here, I know that the coordinate of c, the x coordinate of c is this one, the negative one. Okay, now I am going to, so this over here, this is not applicable in this case. Since x is equal to negative 4 over 3, therefore y will be equal to y, which is given by x to the power of x minus, it's f of x plus x minus 2 to the power of 2, and then x plus 3. Then over here, we're going to sub in the value of x in order to find y. X is negative 4 over 3, negative 4 over 3. Now, we are going to substitute. There we have like negative 4 over 3 minus 2, close brackets to the power of 2. And then open brackets here again, and then negative 4 over 3 plus 3, and then close brackets. And then when we press equal, we have like 500 over 27. And then if you press SD, this is 18.1350 recurring. So this number recurring. So we can, to the second decimal place, it can just be 18.52. So y will be equal to 18.52. Therefore, the point C is negative 4 over 3 and then 18.52. Thank you. You got a question? Is there any other? The question 8.4 says, for which value of x will f be concave down? All right. The function concave down if the second derivative of that function is less than 0. Now I'm gonna write here 8.4. We're looking for those values of x for which the function will concave down. So now we know that f of x concave down, so meaning concave down this way if the second derivative, okay, is lesser than 0. Now the first derivative we find was given by 3x squared minus x, let's see, the second derivative was 3x squared minus 2x minus 8. So over here minus 2x minus 8. So that's the first derivative, meaning the second derivative will then become 6x minus 2. Okay, now we're going to set this lesser than 0. Now, this means 6x minus 2 is less than 0. If I move the 2 over, and then x will be, okay, by 6 and by 6 there, that makes x is equal to, x must be lesser than 1/3. Thank you.